Excess charge on an ordinary atom, Physics 2212, Lab 1. The purpose of this lab is to visualize and understand how everyday items can become charged and how they interact with other objects, as well as to determine how much excess charge is on an item. In order to do this, we created charged pieces of tapes and used observed interactions and physical concepts, as well as equations, to conduct calculations. From this experiment, I found that the tape was negatively charged with an excess charge of 1.4 times 10 to the negative 8 coulombs. In this lab video, I'm going to go over the main concepts, part 1 of the lab, part 2, the discussion questions, and the calculations and code. The main concepts associated with this lab are electric force, which is the attraction or repulsion of two charged objects, Coulomb's law, which is a law stating that like charges repel and opposite charges attract, and as well as forces in equilibrium, which is when the net force acting on an object equals 0. For part 1 of this lab, we created two pieces of charged tape by sticking a piece of tape on top of another and ripping them apart. In order to determine the sign of the charged tape, we observed interactions with the different objects and applied Coulomb's law. When putting the charged tape near neutral objects, I found that the charged tape was attracted to the object, which was expected due to polarization. When putting the charged tape near another charged tape, I saw that the pieces of tape repelled, which was also expected due to Coulomb's law, and they are like charges. When putting the piece of tape near a positively charged pin, I saw that the tape was attracted, which showed that the tape was negatively charged. For part 2 of the experiment, we created a floating tape setup and used the concept of equilibrium to do force calculations. For this setup, we needed to assume that the tape charge was located at a single point in the center of the tape, as well as that both pieces of tape had the same amount of charge. From here, we saw that the initial top piece of tape was floating and not moving, which showed that the forces acting on the tape were in equilibrium, and the only forces acting on the tape were the electrical force from the piece of tape below and gravitational force. This showed that the electric force from the piece of tape below must be equal to gravitational force. Knowing this, we could then apply the electric force formula, which is force equals Q times E of electric field, and then use the electric field point charge formula to solve for the Q. So in order to do this in the calculations, we needed the mass of tape, which was determined to be 0.0021 kilograms, the distance between the floating tape and the stationary tape, which is 0.03 meters, and then we solved for the gravitational force, which was the mass of the tape times the gravitational constant, and that came out to be 1.96 times 10 to the negative 3 newtons, and the electrical force was the same magnitude but opposite directions. We then plugged in the point charge formula and solved for the Q in order to get the excess charge of 1.4 times 10 to the negative 8 coulombs. Then to solve for the number of excess electrons, we divided the excess charge by the charge of one electron, and this came out to be 3.945 e to the 10 electrons. To get the ratio of excess electrons to atoms on the sticky surface, we had to get the amount of atoms per piece of tape, and to do this, we determined the length of the tape to be 0.19 meters, the width of the tape to be 0.02 meters, that diameter of an atom to be 1 times 10 to the negative 10, and determine the atoms per the length of tape, the atoms per the width of tape, and then multiply these together to determine the atoms per the entire piece of tape. We then determined the ratio of electrons to atoms and determined it was 1.04 times 10 to the negative 7. All of these calculations I did within the glow script, and I did them in the exact same order as the previous slides. So determining the electric force and the charge, then the number of electrons, then the number of atoms. And these are the results that came from the glow script code, with the two dots representing the piece of tape and the arrows representing the forces acting on the top piece of tape. Some additional questions to consider. What if the electrons had positive charge and the protons had negative charge? What would change about the observations made with the tapes? If this was the case, the electrons if the electrons have positive charge, the results would be similar in that the charge of the tape would be the same magnitude but a different sign, and the tape would still repel other charged tapes and attract neutral objects, but instead of attracting the positively charged pin, the tape would repel it. And then, why is it important to handle the charged tape as little as possible? Because when your hand comes in contact with the charged tape, it loses some of its charge through the transfer of electrons. So the more you handle the tape, the more of the charge it's going to lose.